So this is Roger with Asymmetric, and this is going to be the Con Ed 14th Street Augmented Reality proposal. Asymmetric has been asked to produce a 3D model of the 14th Street power plant for Con Ed. During this presentation, we will go over what that will entail, including the type of 3D model needed, how we will capture the data needed to create the model, what post-data collection processing will be needed, and the capabilities of the final deliverable. So the problems we've been asked to solve, we've been asked to produce a 3D model of the inside of the 14th Street power plant. With the model, we need to be able to capture an easy-to-navigate map that can be used to aid in providing direction to different assets and elements within that plant. Using BIM, IoT, and AR/VR, we need to integrate this model into the existing building management system Con Ed currently has. We need to make the process of handing over the 3D model digital twin as easy as possible. So what is a digital twin? Digital twins use real-time and historical data to represent the past and present and simulate predicted futures. A digital twin is a virtual representation of real-world entities and processes synchronized at a specified frequency and fidelity. BIM is a set of interacting policies, processes, and technologies generating a methodology to manage the essential building design and project data in digital format throughout the building's life cycle. IoT, or Internet of Things, describes a network of physical objects that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data. Augmented reality/virtual reality refers to computer-generated simulations that integrate the real world, AR, or are entirely self-contained, VR. Digital twins are motivated by outcomes, tailored to use cases, powered by integration built on data, guided by domain knowledge, and implemented in IT/OT systems. So as we're looking at the value chain, you can see where the data management will fit into the sense making and decision making. There's multiple types of digital twins. We have the component, asset, process systems, network systems. There's different levels of sophistication of these. We have descriptive, a visual replica of assets, facilities, and products, a 3D model of a plant, geospatial maps, and building information modeling, BIM software. There's informative, partial or full integration with sensors, IT, and business software systems, maintenance, and operational data. Provide insights into basic parameters, conditions, or performance of an asset at particular points in time. Understanding normal baseline working conditions and insights into anomalies. What happened and why. Predictive IT/OT integration provides more granular data in real-time, near-time, real-time. Advanced analytics and machine learning applied to big data to identify patterns and provide early warnings, inclusion of contextual data, and learning from similar events or assets. Comprehensive, physics-based, asset-based, or first principles-based modeling. Real-time simulation of what-if scenarios. Prescriptive analytics based on industry, product, best practices, recommended actions to be taken. Transformative, vendor agnostic integration with multiple real-time data feeds, advanced algorithms for modeling and simulation of an entire plant, facility, or large asset. Predictive and prescriptive analytics, machine learning, and AI, 3D visualization. High-speed computing power integration with AR and VR. Ability to take decisions to correct issues autonomously. So all of these work together to make what is the end goal. The BIM, machine learning and AI, real-time monitoring, analysis, visualization, AR, VR, asset management, reporting. These will accelerate operational readiness, operate through a single pane of glass, provide insight across your portfolio, and future-proof your built asset. So how this works, this is one of the examples. We'll import the data with third-party plugins using Unity, Reflect, as well as Autodesk, that will provide us with a model that we'll be able to integrate into different platforms such as the PC, Mac, iOS, VR, AR, Android. Using the Autodesk plugins, it will allow us to create the 3D model and digital twin in different versions for different applications depending on what we decide is the final end goal or required use of the model. Is the Unity Reflect augmented reality example, and here is Unity's headquarters. This is one of their hallways. You can see with Unity and Autodesk Reflect, you're able to create these models, and you can see here some of the processing that's going on behind the scenes. This is an example that Booz Allen Hamilton used for a hospital. You can see they have the different elements of the hospital labeled with those sensors. You can see the individual people walking around. This is another example they used. You can use these models to maintain a better understanding of what each area would need as far as inventory, keeping track of those things. Each one of those dots represents the sensors picking up people walking, so you can tell if somebody goes into an area, and you're able to keep track of when they would go out, which would help provide better, safer policies and operating procedures. This is the Leica camera LiDAR scanning that we recommend using. This is the Leica 360 Black. So our proposed solution: by creating a digital twin of the 14th Street power plant, we can aid in building management and aid in projecting this asset through keeping track of its needs in an easy to navigate way. So this is going to be a 3-phase process. Phase 1 will be the data collection. We will scan the building with LiDAR cameras from the inside. Phase 2 will be the data processing. We will import the data into post-processing software to create 3D models in digital twin. And Phase 3 will be model presenting in BIM. We will deliver the constructed model in digital twin and aid in handing it off to be incorporated into building management with existing systems. So as far as the deliverables go, the plant itself is 43,000 square feet. The Leica Black 360 allows for dimensional accuracy within 0.1%. So the plant being 43,000 square feet, the estimated scanning time typically is between 5 to 10,000 square feet per day. And we anticipate between 4 to 8.5 days to scan. For the modeling in general, you can assume it will take about 4 times that amount of time it took to scan, depending on what the final deliverable will be. So our vision with this is integrate the digital twin into the BIM for the 14th Street to allow for additions in the future if the plant is expanded upon. That will allow for real-time tracking with sensors to facilitate more efficient processes and safer operations. Later, we can use this same process for the other Con Ed plants, create digital twin of the other plants to be integrated into the overall BIM of Con Ed as a whole. We can then take this further and use this for each of Con Ed's assets, so we can include digital twins of each substation as an example, and Con Ed asset to maintain the most sophisticated management of them and improve operational efficiency across the board. This will help create a faster response to each of the assets' needs. Complete integration of digital twins into overall asset inspection and maintenance operating procedures would allow for more effective and efficient tracking, and any additional expansions in the future could be easily integrated into this overall BIM, which would allow for digital twins of each addition to be integrated and managed into an overall BIM system. So that concludes this presentation, and I thank you for your time.